In this video, I will show you how to graph a piecewise function and determine the domain and range and points of discontinuity. So, you have these two different pieces. I'm going to do them in two different colors. This will be the blue function, the blue piece, and this will be the red piece of the function. Now, over here on the end, we have the domain of the piecewise function. The number that you see in the domain will tell you the endpoint of that piece of the graph. So this is an x value, so I know that the endpoint is going to be 1 comma something. I need to know the y value that goes with this x value. So I think I'll just do that down here. So the blue function is the square root of x plus 3. So if I want the y value, I have to substitute in the 1. So that's the square root of 1 plus 3. So that's the square root of 4. So that is 2. So that tells me that 1 comma 2 is going to be the endpoint of this piece of the function. Now it's going to be a closed circle because it says x values greater than or equal to 1. So closed circle at 1 comma 2. So 1 comma 2 closed circle. This is the end point of this piece of the graph. So we want this function applies for x values that are greater than or equal to 1. So you should be thinking, okay, so basically to the right of 1. So we're going to have this function, but then we're going to be going to the right from here. So let's go ahead and do a table of values so we get a few more points going to the right. We already have our first x value, so that's cool. That's cool. Our first x value is 1. If I'm going to the right, then I'm going to do, like for example, 2 and 3. And then let's see where we are at that point. Okay, so when we did 1, we got a y value of 2. So let's see, remember that the function is the square root of x plus 3. So the y value is going to equal the square root of x plus 3. Okay, so what about when the x value is 2? Then that would be the square root of 2 plus 3. Okay, so that's going to be the square root of 5. And what is the square root of 5? He said as he grabbed his calculator. The square root of 5 is approximately 2.2. So that would be 2.2. Okay, interesting. All right, what about, and I can already tell I'm going to need some more points, 4, 5, and 6. What about if the x value is 3? If the x value is 3, then that's going to make this 3 plus 3. So that's going to be the square root of 6. All right, and the square root of 6 is 2.4. Wow, these are not going up very fast. If x is 4, then that's the square root of 4 plus 3. So that's the square root of 7. And the square root of 7 is 2.6. Okay, and then if x is 5, then I will have the square root of 5 plus 3. So that's the square root of 8. Which is 2.8. And then finally, if I do 6, then that would be the square root of 6 plus 3. That's the square root of 9. And finally, I get a whole number. That's going to be 3. So here I have a nice little table of values that I can use. So 2 comma 2.2. So that would be just about here. And then 3 comma 2.4. 4 comma 2.6, 5 comma 2.8, and 6 comma 3. And then we can go ahead and just draw this graph going to the right. Okay, now this looks almost linear, but it's not. Okay, a square root graph actually has this type of a shape to it. Okay, this is what a square root graph looks like. But what's happening is, if you look at just this part of the graph, that's, for example, it goes from here on, it can start to look pretty linear. So that's what we're dealing with. Anyway, that's the first part of this piecewise function. That's the first piece. Now it's time to graph the other piece. So let's start with the endpoint. Again, this is the x value of the endpoint. So it'll be 1 comma something. The y value is going to be what I get if I plug in the 1. So that's just going to be negative 1. So 1 comma negative 1 is the endpoint of this piece. It'll be an open circle because it doesn't say or equal to. So 1 comma negative 1 open circle. Okay, that's the endpoint of this piece. Now you should be thinking we're going to the left. We want x values that are less than 1. So that's going to be values to the left of 1. I don't need a table of values for this because I know that this is linear. Like think y equals mx plus b. Hold on. If you think about y equals mx plus b, and now this is y equals negative x. Okay, so the slope must be negative 1 because of that little negative sign. That means down 1, right 1. So if I were going to the right, I would go down 1, right 1 like this. But I need to go to the left, which means I have to go backwards. I have to go up 1, left 1, like this. So this is actually the direction I'm going to draw, again, because I know from the beginning I have to draw to the left. Okay? It will help you avoid certain mistakes if you keep in mind that your graph should be passing the vertical line test. So say if I accidentally drew the wrong direction. Say if I got confused and I drew my graph going in this direction. Well, that would fail the vertical line test over here. Okay, so you can't have both of these lines going the same way. So use that to help you avoid common mistakes. So that's it. That is the second piece of this piecewise function. So that's it for the graph. Now let's talk about the domain and the range. Hopefully you can understand that the domain is going to be negative infinity to positive infinity. Okay? And I can help you understand that because I'm just going to highlight the domain of each piece. Consider the domain of this red piece. It goes from negative infinity to 1. Now consider the domain of the blue piece. It goes from 1 to positive infinity. But if you put them together, there are no gaps. So that's why the domain is negative infinity to positive infinity. Okay, now let's do the range. Okay, so the range, get my highlighter back. First, let's do the range of the red part of the graph. So I'm doing the range, so I'm going to stick to the y-axis. So vertically, it goes from negative 1 to infinity. Okay, if I look at the y-axis, The red part of the graph has a range of -1 to infinity. Okay, now how about the range of the blue part of the graph? Well, the blue part of the graph goes from 2 to infinity. Notice how I'm just highlighting over what I already had highlighted. So the blue part of the graph really didn't add anything to the range that I didn't already have covered. So everything that you see highlighted, that's going to be the range of the overall function. So notice that I'm not doing two separate ranges. This is one function. You have to look at it all together. So if you highlight the y-axis, it will make it clear. If there is no gap in your highlighting, you will not have two separate parts to your range. So the range goes from -1 to infinity. We will have parentheses at -1 because this is an open circle. Okay, so the range is from -1 to infinity. Okay, let's talk about the points of discontinuity. The points of discontinuity are the x values of the gaps. Okay, look and see where are the breaks in the function, where are the gaps, and wherever the gaps are, then what are the x values right there. This function only has one break in it. Okay, we have one gap right here. The x value is 1. So that's the point of discontinuity, is x equals 1. So that is actually it for problem number 5. All right, take a look at problem number 6. We have 3 pieces to this piecewise function. All right. I will do the first piece in blue. I will do the second piece in red. And I will do the third piece in green. All right, this is a 3-piece piecewise function. Let's start with the blue piece. This piece is going to have an endpoint. All right, this number in the domain will lead me to the endpoint of this piece of the graph. This is an x value, so -1 comma something. I need the y value that goes with this. So remember, this is like y equals 2x plus 3. So y equals 2 times -1 plus 3. What's that? See, do I have space over here? So this is -2 plus 3. So that's 1. So the y equals 1. So this is going to be the endpoint. This will be an open circle because it doesn't say or equal to. So open circle. So -1 comma 1, open circle. This is the endpoint of this piece. Now, because it says less than -1, you should be thinking, okay, we want values that are going to the left of -1. Okay, so we want values going to the left. This is linear. Whenever it's linear, I don't need a table of values to do it. Because I just use the y equals mx plus b. Okay, so and all I really need is the slope. Notice that the slope is 2. That's 2 over 1. Rise over run is 2 over 1. Okay, so if I were going to the right, I would go up 2 over 1 like this. But I don't want to go to the right, all right? We want to go to the left. So I need to trace this pattern in the other direction. So instead of going up 2 over 1, I need to go left 1 down 2. So left 1 down 2, left 1 down 2, left 1 down 2. So this is going to be the blue piece of the function. And I'll just erase this extra dot that I didn't really need. So that's the first piece. So let's move on and graph the red piece of the function. Now this is not linear, so at some point I probably will need a table of values. Okay, let's use these numbers, the -1 and the 2, to find the endpoints, plural, the endpoints of this piece of the function. Okay, so the first endpoint will be at -1 comma something. And then the second endpoint will be at 2 comma something. All right, I need to figure out what these y values are. So I guess I'll just do my calculations down here this time. So I know that y is equal to the absolute value of x minus 5. That's what this piece of the function says. So if the x value is -1, okay, then that's going to give me y equals the absolute value of -1 minus 5. So that's going to be +1 minus 5. So that's going to be -4. So -1 comma -4 is the first endpoint. Now let's do the second endpoint. If the y value, if the x value is 2, then I have y equals the absolute value of 2 minus 5. So that's just going to be 2 minus 5. So that's going to be -3. So 2 comma -3 is another endpoint. Both of these should be closed circles because it says or equal to -1 or equal to 2. So these points will be included, so closed circles. So -1 comma -4 closed circle. And then 2 comma -3 closed circle. Okay. Let's do a quick little table of values to find out the y values at 0 and 1. And in other words, I need to know what's going on at these 2 points. I cannot assume that it's just going to be a straight line right here. Okay, maybe it is, but maybe it isn't. So what about when x is 0? Okay, if x is 0, then I've got y minus y equals the absolute value of 0 minus 5. That's going to be 0 minus 5. That's going to be -5. Okay, so when x is 0, the y value is -5. So that's going to be right here. What about 1? When the x value is 1. When the x value is 1, then I will have y is equal to the absolute value of 1 minus 5. So that'll be 1 minus 5. So that'll be -4. So when the x value is 1, the y value is -4. That's going to be right here. So notice this did not make a straight line. It makes this V shape. Okay, so between the 2 endpoints that I had from the start, this is what happens in the middle between them. So this is the red piece of the piecewise function. Okay, but there's one more piece to this piecewise function. It's this green piece. Again, this number in the domain is going to lead me to the end point of this piece. It's going to be 3 comma something. I just need the y value. Well, this piece of the graph is really the function y equals 1. So notice there's no x to plug into. We don't need it because y equals 1 automatically. So guess what? Y equals 1. So you just make the y value equal to 1. So 3 comma 1 is the end point of this piece. It should be an open circle because it's not or equal to. So 3, 1, open circle. Okay. Now, because it says greater than 3, you should be thinking, oh, we want the values that go to the right from here. Understand that y equals 1 is a horizontal line at 1. So keeping that in mind, I've got a horizontal line, but I'm going to the right, so it's going to look like this. Okay, that's done. So now let's talk about the domain and range. Okay, when I do the domain, I will highlight the x-axis. When I do the range, I will highlight the range on the y-axis. So, we can do the domain one piece at a time, but then we will have to step back and look at the domain as a whole. So what is the domain of the blue part? On the x-axis, the blue piece goes from -infinity to -1. What's the domain of the red piece? Well, on the x-axis, the red piece goes from -1 to 2. What's the domain of the green piece? Well, the green piece goes from 3 to infinity. Notice the gap. There's a little gap in here. So when I do the domain, I'm actually going to have to do the domain in 2 separate pieces. So the first portion of the domain goes from -infinity to 2. Notice I don't need 3 separate pieces. There's only one gap here, so I only need 2 pieces when I do the domain. Don't just try to do a separate domain for each part of the graph. Only split up the domain if there's an actual break in the domain. So -6 to 2 is going to be my domain. -6 to 2. Now I need to, oh, I don't mean -6. This is -infinity. Okay, -infinity to 2. I almost said -6 because that's just where the graph paper ended, but this is -infinity to 2. Now, at 2, I have a closed circle. So when I say -infinity to 2, I should make this a bracket. And then I'm going to say union, and now I'm going to say the other part. So this part goes from 3 to infinity with an open circle, so parentheses. So parentheses 3 to infinity. So there is the domain of the overall function. So now let's switch it up and talk about the range. As I consider the range, I will highlight the y-axis as I go along. What's the range of the blue piece? Well, the blue piece of the function goes from -infinity to 1. What is the range of the red piece? Well, the red piece goes from -5 to -3. All right, that's the low and the high. Notice how I just re-highlighted what was already highlighted. So nothing has really changed. I could erase this middle piece and it wouldn't affect the range. Now, what's the range of the green piece? The range of the green piece is just a single number, the number 1. Okay, so that is a little bit tricky because I already had highlighted up to 1, but this was an open circle before. So the point 1 actually wasn't included before. But now I am going to include the number 1 in the range. Not because of this open circle, because the open circle still doesn't count as a point. But this arrow represents infinitely many points. This is a zillion, billion, cajillion points. And so they are not open circles. They count. So they all have a y value of 1. So a y value of 1 must be included. So bracket. So this is going to be negative infinity to 1 with a bracket because of all these points. Again, notice the range is written just in one piece. I do not have 3 different little ranges for the separate graphs. You have to give me the range of the overall graph as a whole. Okay, points of discontinuity. So one more time, remember that points of discontinuity are the x values of the gaps. Okay, so let's see where are the x values of the gaps. So we have 2 gaps that we have to deal with. So we have one gap right here. This gap has a single x value, and that is -1. So one point of discontinuity is x equals -1. Now let's deal with the other gap. This one is special. We have this gap here, but what is the x value of this gap? This gap stretches. It's not a single x value. It's all the x values from 2 to 3. All right, they're all gaps. So the way I write that down, I will just say, I will just use interval notation, and I will just say 2 to 3. So if you just have a single x value, then just put the single x value, like x equals -1. But if you have a horizontal gap like this, okay, where it drops off at 2, and then it picks up again at an x value of 3, then you have to put an interval for that. Drops off at 2, picks up again at 3. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.